Hi, my name is Zainida Camelia, gonna present to you about process coordination and the subject operating system. A simple introduction about what is operating system. Operating system is the software layer that manage and control computer hardware and the software resources. Its role is a resources manager that will allocate CPU time, memory, and I/O device to process. I/O is input or output devices. Also, as a user interface, it provides an interface for user to interact with the system. And also, its role is a protection layer to hide hardware complexity from the application. Next is a process synchronization. Process synchronization is one of the subtopic in the process coordination. If you think about the process synchronization, you can imagine a bustling city with a multiple vehicle sharing the same road network without traffic rule and light, and also the coordination, chaos will ensue. Similarly, in a multi-process system, process need to access shared resources in an orderly manner. Process synchronization is the art of coordinating execution among multiple processes. There is a few techniques that a process synchronization do. One is a semaphore. You can think of this as a traffic light for process. They control access to shared resources. Second is monitors. It was a high-level construct that encapsulates shared data and provide a mutual exclusion. Next is a critical section. These are like a VIP lens only. One process can execute within at a time. And then there's example. For the process synchronization, you can picture a multi-threaded application where threads share a common printer. Without synchronization, simultaneous printing could lead to the gibberish output. Next is our main topic, which is a process coordination. Process coordination is to ensure that multiple processes within an operating system or the distributed environment work together efficiently. It will facilitate seamless communication, resource sharing, and prevent conflicts. There's a few key concepts that you need to know in process coordination. The first one is a message passing. Message passing is a process communicate by sending message with advantage of a simplicity and support various communication pattern, one-to-one, one-to-many. As example is a client-server data exchange. Next, key concept is a shared memory. Is a process share a common memory region. Its benefit is ideal for a large data set, also efficient data exchange without message passing overhead. As example, we can take a parallel processing in scientific simulation. And for example of process coordination, we can take when we do online banking. You want to do two process, which is process A. You want to deposit money into the third party account. Process B, you want to withdraw money from the account. So, coordination is a must to ensure consistency. Lack of prevent simultaneous access to the same account. And message passing, that when you do the transaction, at the end of the process, you will get a message that confirm the transaction is complete. Next subtopic in a process coordination is a asynchronous state. What is it? You can imagine it as a bustling city where people move at different pace, each with their own agenda and destination. A synchronous state in computing this diversity. So the definition is an asynchronous state occur when process or events operate independently of each other without the fixed timing interval. So there's a few characteristics for the asynchronous state, which is there's a no fixed interval. The process don't wait for predefined bits. They act when ready. Second is concurrent execution, which is multiple tasks perform their step simultaneously. As example, you can take email communication. When you send an email, it will send and travel asynchronously through server, reaching its destination without waiting for the other email. And next is the reason why we need a process coordination and also the process synchronization, because it will create a deadlock. So what is a deadlock? You can imagine it as a busy intersection where 2 cars or 3 cars are stuck. Each is waiting for the other to move. So in the computing, this scenario occurs when 2 or more processes are stuck and waiting for each other to release the resources they are hold. It's like a traffic jam where no one can move forward. So the condition for deadlock is when a mutual exclusion, where its resources cannot be simultaneously accessed by multiple processes. Example is a printer cannot print 2 documents at once. It will wait. And then the condition is hold and wait, which is a process hold some resources while waiting for others. So the solution is allocate all required resources upfront, though it may lead to low resources utilization. Next is a no preemption, which is resources cannot be forcibly taken away from a process. As example is once a process holds a printer, it won't be preempted. And then next is a circular wait, which is processes form a circular chain, each waiting for a resources held by next. So the solution is we can assign numerical priorities to the resources and allow requests only in increasing order, so the deadlock doesn't happen. That's all from me. Here is a little summary for process synchronization and coordination. The process is to ensure efficient communication and resources sharing. This technique, like a message passing and a shared memory, play a crucial role. Do remember, seamless collaboration leads to a better system performance. Next, please avoiding the deadlocks. Deadlocks halt all progress when processes wait for each other indefinitely. Understand the 4 deadlock condition: mutual exclusion, hold and wait, no preemption, and circular wait. Do prioritize thoughtful resources allocation to prevent the deadlock. Next is a little bit from me, a thoughtful system design. Design a system with a synchronization and coordination in mind. Consider a trade-off between responsive and resources utilization. Encourage best practice to maintain the system integrity. Thank you.